Okay, this is the last one, question 3e. So this is quite a hard one to set up for a start. Absolutely, so let's work through this. So the engine on a ship fails when it's sailing on the ocean. The velocity decreases at a rate inversely proportional to the ship's mass. So when it's inversely proportional, that means we're dividing by m. And we're just going to put K or C, we're just going to use K as the proportion. So we're going to just use that. So the velocity decreases at a rate, so we're going to do V by dt equals, so inversely proportional to the ship's mass, and directly proportional, so that means it's on the top line, I guess, directionally to the square of the velocity. So we're just going to times that by the velocity squared. Okay, so when it's inversely proportional, you're going to divide it by the m, and when it's directly proportional, you just times it by it. But because it was the square of the velocity, we go v squared. All right, we've got a whole lot of stuff here. Now, K and M, remember, are constant. Okay, my velocity is constantly changing, but K and M are constant. So we're going to leave those by themselves on that side, and we're going to take over the dt. But I'm going to take the v squared over the other side and make it 1 over v squared and leave the dv over there. Just matching up our variables. I know we've got k and m then too, but they're actually numbers. We just don't know what the numbers are. Okay. So when we integrate that, we're going to bring it up to the top line. So v to the -2. So k over m is just a number, remember. So when we integrate that, so that's going to be v to the -1 over -1. Equals km, and we're just going, because we're integrating with respect to t, we just put a t at the end of it, and we're just going to put plus c. Okay, we'll tidy this bit up. So v to the -1 just means the v belongs on the bottom line, and because of the -1, we're just going to put a negative out the front. All right, let's fill in some gaps here. So what we know is that when the engine's failed, so that's when time is 0, then it's 8 meters per second. So when t is 0, my velocity is 8. We also know that 10 minutes later, it reduced to 6 meters per second. Okay. Now, remember, we've got to get, this is per second. So remember, we need to change that to seconds. So 10 times 60 is 600. So we're going to use 600. So when t is 600, our velocity is 6. Okay, so let's come down here. So when t is 0, v equals 8. So -1/8 equals this bit 0. This bit here is going to be 0. So that means c is going to be -1/8. Okay, so now we've got -1 over v equals kmt minus 1/8. We also know when t is 600, my velocity was a 6. So therefore k over m times 600 minus 1/8. So we can play around with this a little bit. So we're going to add an 1/8 over to this side. We're going to add the 1/8 over that side, and then we're going to take the times by 600 as well, and divide by 600. So that becomes -1 over 14,400 equals k over m. And now we've got an equation for it. So now we've got -1 over v equals, we know what our k over m is. It's -1 over 14,400 t minus 1/8. Okay. What will we ask for? To determine how long it would take to reduce the v to 1 meter per second. Okay, so we're going to replace our v with 1. So that's -1. Oops, let's change the t minus 1/8. So that's 1 and 1/8. Add the 1/8 over the other side, so that becomes -7/8, and then times that by 14,400, and we get t as being 12,600 seconds. You can divide by that by 60 if you like to find out how many minutes, and divide by 60 again to find how many hours. And that